Every year it's like clockwork. The headlines start popping up about Delhi's choking air quality. But what if this isn't some surprise disaster? What if it's actually a totally predictable outcome of a system working exactly as it's designed? That's what we're going to break down right now, the real reasons behind this annual crisis.
Right, let's just start with this core idea. This isn't about panicking or pointing fingers at one single thing. It's about understanding the actual mechanics of a problem that just keeps coming back. So, we're going to unpack this system that produces this smog year after year.
So, where does all this pollution even come from? Well, the first thing to get is that there's no single villain in this story. It's much more like several different problems all stacked on top of each other, and each one makes the others even worse. Okay, let's start at the bottom of that stack, the baseline. Every single day, you have millions of cars, buses, and trucks on the road in and around Delhi. This creates this constant, low-lying blanket of pollution that the city just lives with all year round. Think of it as the foundation of the problem. Now, on top of that traffic, you have a city that's constantly growing. All that construction, new buildings, new roads, it turns up these enormous amounts of what experts call fine particulate matter. Really, it's just a fancy term for dust and other tiny particles that get into the air and are just awful to breathe in. And the next layer? That comes from all the industrial zones surrounding the region. You've got factories, power plants, and they're all contributing their own unique mix of pollutants into the atmosphere. It's just another source getting added to this growing stack. And then you get the seasonal trigger. This is the one that really tips the scales. For a very specific period each year, farmers in the neighboring states burn what's left of their crops to clear the fields. This just injects a massive, concentrated cloud of smoke straight into the air. And it drifts right over the region, pushing the pollution levels from bad to what is even happening? So here's the crucial point. If you took any one of these on its own, it might be manageable. But when they all happen at the same time, they compound. They stack up and create a problem that is way, way bigger than the sum of its parts. But producing all of this pollution is really only half the story. Let's move on, because it's not just about what's being put into the air. The real kicker is why that pollution can't seem to escape. And this is where geography and weather step in and create what's basically a natural trap. See, Delhi's landlocked. It doesn't have a coast with sea breezes to come in and blow all the pollution away. And to make things worse, in the winter, the wind speeds just drop. The air gets really still, and it doesn't move up or down very much. This creates this lock-in effect where the air just sits there, trapping all that pollution right at ground level where everyone is breathing. And this brings us to a specific weather phenomenon that pretty much makes everything worse. It's called a temperature inversion, and it acts like an invisible lid that gets clamped down on top of the city. Here's how it works. Normally, the air near the ground is warmer, so it rises, right? And it takes pollution up and away with it. But in the winter, you can get a layer of warmer air that forms higher up, trapping the cooler, denser air below. And that trapped air, which is now full of smoke and exhaust, has nowhere to go. It can't rise, it can't spread out, it just sits there and gets thicker and thicker. So when you have these compounding factors, this stack of pollution sources, and this invisible weather trap, you can see why a crisis happens. So let's take a look at how this crisis is usually handled and, well, why the things we see being done often don't seem to work in the long run. On one side, you have all the emergency measures we hear about every year, restricting which cars can drive, putting a temporary stop on construction. These are the short-term fixes, the band-aids. But on the other side, you have the real long-term drivers of the problem. We're talking about fundamental decisions about urban planning, how we all get around, where our energy comes from, and how different states actually coordinate with each other. And this, right here, is the key takeaway. Putting a band-aid on the problem every single November is crisis control. It's absolutely not a structural solution. Managing the symptoms is not the same thing as curing the underlying disease of the system. So when you put all these layers together, the multiple pollution sources, the weather trap, and this focus on temporary fixes, you end up with a system that is perfectly designed not to solve the problem, but to repeat it. This whole cycle repeats because, well, for one, the solutions are fragmented. The sources of pollution and the people affected are spread across different states, and everyone has different policies. The focus always ends up being on reacting to the crisis once it's already here, instead of preventing it months ahead of time. And fundamentally, a lot of the region's economy is just tightly linked to these polluting sources. So every year, the exact same conditions come together to create the exact same outcome. So the central finding here is pretty clear. Delhi's air pollution isn't some big mystery. It's a known outcome. It's a predictable result of geography, weather, and a whole bunch of policy decisions all interacting over time. And as long as that system stays the same, the result is pretty much inevitable. And so we'll just leave you with this final thought. The conversation probably shouldn't just be about the smog itself, but about the system that creates the smog. I mean, if we can predict the problem with this much accuracy, the real question becomes, what does it actually take to change that predictable outcome?